Specific heat is a physical property that says how much heat a substance needs to absorb in order to warm up. It also tells you how much heat a substance gives off when it cools. Specific heat, lowercase s, is the units are joules for the heat, per gram, the amount of substance, per degree C. So we have this equation that relates the heat to the specific heat, the mass of the substance, and the change in temperature. The change in temperature is the final minus the initial. So if something is cooling, this delta T term will be negative, which makes Q negative, which makes sense because it would be losing heat. So let's look at this problem. We start with, in this case, the metal is cooler. It's at 25 degrees and it's placed in water that is 85. So we have a cooling situation here. The 25 grams is for the metal. We need to keep track of which numbers go with which thing. This is what the metal starts off with, so a T1 for the metal. And then this is for the water, and we know we can get the mass of water from that, so I'm going to go ahead and call it the mass of the water is 100 grams. Then the water cools from, so this is a T1 for the water, and then this one is the final temperature, and it will be the final temperature for both. The heat transfer will occur until both metal and water are at the same temperature. Okay, so if we look for this equation, we have more information about the water. We have the delta T, the mass, and the specific heat for the water, so we can solve for the Q for the water. You need to be careful that I'm putting in all of these numbers for water and not getting them mixed up. So for the water, and I'm going to move this over here, we are given our specific heat. The mass of the water was 100 milliliters, but that's 100 grams of water. And then for the change in the water, I've got the temperature change here. And we can see our units do cancel. Our grams down there cancel, our degrees C here cancel, which leaves us with joules for our Q. We need to watch the sig figs because when we do this subtraction, we lose sig figs because we use the add subtract rule. So we know we need to drop down to just 2 sig figs for our answer. So 2 sig figs. I'm going to keep more digits here, but know at the end to round off for 2. Okay, and then what I know is that the Q for the metal is the same number, opposite sign, as the Q for the water, because all of the heat that the water is giving off is being absorbed by the metal. So I'm going to change this. Oops, looks like I lost a negative sign there. That should be negative. The water is cooling. So the Q for the metal then is, it's a positive. Oops. Okay, so then I can set this up. And this time put in the numbers for the metal. Again, 2 sig figs on that. I'm solving for the specific heat of the metal. I have the mass of the metal. And the change in temperature for the metal. So that T2 was the same for both. And then, let's see. So I'm going to watch my sig figs here again, just to be sure. This one doesn't lose any. So I'm going to end up with 2 sig figs because of my Q. So I'm basically dividing this number by all of these, and everything but joules will cancel. No, that's not right. Let's follow the units. So nothing's canceling, is it? So I'm going to go ahead and show dividing so I can look at the units. And of course I'm dividing both sides by all of that, so I'm not showing it because it'll cancel on this side. And so I get 0.90, 2 sig figs. And then let's look at these units. I have joules divided by grams degrees C, which is, those are the units for specific heat.